Okay, so firstly, we go for our chemical structure drawing. Okay, later you can see two parts. At the top there, April 20 and 19. And the bottom, the red color, September 20 and 19. So I will give you example at the top of the black, which April 20 and 19. Then afterward, you answer for me for the second part. Can? We do it together. Okay. So normally in the chemical structure, we give the structure based on mostly from benzene compound. Okay. Then afterward, anhydride, it should be the second. And normally we come out with one ester. For those long carbon chain, the side chain with the diethyl, dimethyl, seldom will come out. Because this one come out already during test 1 and test 2, we won't come out secondly in the final. We go to more higher difficulties. Yeah, okay, for example, aniline. In your mind, you have to know about aniline should refer to a benzene ring, then attached with NH2, benzene ring. Okay. Then methyl, you know, is referred to CH3 located at O. O refer to ortho. So you can write it down, which is O my paradise. Okay, O refer to here. So you can give the answer, which is here. NH2, then followed by CH3. Can I? Ortho, okay. Or some students say, Mr. Lim, can I put the CH3 on the left? Yes, but be careful. C first, followed by H3. Okay, here's correct. Either one. Get it? Okay, done already, aniline. Then you have to know we got few of the parts. For example, aniline. For example, phenol. For example, benzyl aldehyde. For example, benzoic acid. Okay, for example, toluene. So these all are considered very famous of the chemical in benzene compound. You must be very to understand about the chemical structure. Can I? Okay. Then next one, anhydride. How the anhydride structure look like? You know, it's referred to C with the O, O, then with the CO double bond. Then attached with two R sites. Two R. So it got butanoic, another is a propanoic. Easy for you. But 4 carbon, prop 3 carbon. Either one side which attached to the number that you have. 4, here's a 1, then you have to attach 3 more. Write it here. Then followed by CH2, CH2, CH3. 1, 2, 3, 4. Bingo. But. Prop. Draw for here. 2 more attached. CH2, CH3. Okay. But one thing to remind you is normally I encourage students to use either expanded or condensed chemical structure. Don't use character unless you really expert. Okay? And okay, then afterwards, now done already for 1, done already for 2, easy. Now we go to number 3. Number 3, you refer to here, butyl followed by benzyl OH. So your mind, you know, this is under ester. In an ester that it should be formed by 2 parts. First part we call hydroxyl. Hydroxyl here, eel to the eel. Then followed by 3-bromobenzaldehyde. So this one is refer to what? Refer to the carboxylic part. Okay. Then you call the ester formula come out, which is RCOOR. This is the ester. Yeah. Then you attach to it. Butyl refer to alkyl. How many carbon? 4 carbon. So we know should refer to CO with 1, 2, 3, 4. 4 carbon. Now attach with the H here. Then here, put 1 more H. 1 more H. Okay, 1, 2, 3, 4. Butyl. Correct. Then afterwards, I know refer to O here. Exactly the same. Then followed by benz. Benz refer to a benzene ring. Okay, carbon number 3 with the bromo. This is 1, this is 2, this is 3. So 3 to bromo. Done already. Okay, so once I rewrite the answer, it can be CH3, CH2, CH2, COO, benzene ring with the BR. This one, cancel. Okay? Okay. I think the answer not so difficult. You just only have to know about the structure. Now, I show you the question. You try to answer it. For correct answer, I will tell you about what is the total mark that you draw correctly in the following part. And for those the first 5, I give it to you bonus mark. So that means you got 6 mark correct. Okay, even though wrong, also I give it to you the mark. For example, 4 mark. Then plus 5 mark for the first 5 students. Attach the answer for me. Do you understand? Okay, be ready. Okay, I will make it like a games. I wish that you can answer it correct and fast. Okay, you know about the format. Should be the best, the good way lah when you answer it. Have you ready? You can write down on a piece of paper. Then you use your handset to snap. Make sure that it's bright for me to check your answer, and make it horizontally through the WhatsApp. Everyone get ready? Okay, here are the answer question. Come. Before I rub it the first. Okay. Hey, can somebody help me to do print screen? Arvin, are you here, Arvin?
Yes, sir.
Can you help me to do print screen before I show you the answer? Can I?
Can.
Okay. This is the first. Done? Arvin, done?
Done, sir.
Thank you. Now I wrap it and I show you the question. Remember, each question I give it to you, then when I say correct, then you come up with a 5 mark. You write down your mark. Then later you check your answer and calculate. Because this one is under, I make it like my educational study. I try to apply a new method. Either you can able to achieve a good answer or not. Okay, here, very ready? Here's the questions. Come, do it now. Number 1, tribromomethyl benzonitrile. Benzonitrile, it refers to benzene with the nitrile, which is a benzene ring, then attached with CN. Remember, C followed by N. Don't attach in between. Carbon number 3, this is carbon number 1, number 2, number 3, attached with bromo. Then number 5 with methyl here. Here's the chemical structure. If correct, mark yourself 2 marks. Erase for those not necessary answer. Okay, correct. Done. Okay, another one. Cis-cyclopen. Cyclopen, I rough up the answer first. This is cyclo. Okay, cyclo. Then afterward, pen-4-in. When you come up with pentene, 4, that means this is alkene. Alkene should be double bond. So this double bond located at carbon number 4, that means is not considered the first priority. What is the first priority? Here, dicarbonyl. When I say it, you have a name with a cyclo with carbo. Carbo means externally it should refer to CO. Okay, then followed by bromide. I repeat, carbon externally we have carbo here, carbo, because it's not under the benzene ring. Carbonyl. Carbon 1 and carbon 3. 1, 2, 3. CO, don't follow by BR. I rough out already. Then followed by Number 4, I got double bond. So this is 1, this is 2, this is 3, this is 4. 4 double bond. Done, okay, not yet finished, because I tend to make it become cis. To become cis, the carbon double bond cannot be show you the cis strand. I repeat, carbon with a double bond cannot show you the cis. The cis and trans conformation refer to the carbon attached with the compound which can show in under the different conformation. This one. So I rewrite the answer. Okay, cyclo, pen, double bond. Then I know I should refer to here. And here. Okay, first one refer to CO with the BR. CO with the BR. Then followed by here is a H. Okay, so correct, 2 mark. So you have to understand this is under eel followed by dibromide. So this one refer to what? Refer to aryl salt. And not aryl salt. So this one is under the acid chloride, acid halide, which is RCOX under carboxylic chapter. Okay, acid halide. Next one. What I'm going to know, I refer to here, amide group. Can you see the amide group? Amide group quickly call out the chemical structure. Okay, the common chemical structure which are CO followed by NH2. This is rough. So we have to understand this chemical structure should be formed by 2 parts. Part number 1 should be the hydroxyl part. Hydroxyl here, this one, hydroxyl part. Then followed by the amide part. Amide should refer to the part of NH2 here. Okay, so how do I draw the structure? So I try to call out, I made a mistake. Okay, once again. When I come up with the N-cyclohexyl, here it should refer to attached with the N here. N. Which N? This one. My mistake, okay, I repeat. Okay, cyclohexyl. Then followed by the N2-diiodobutamide. Butamide, build 4 carbon, refer to the R over here. Okay, so for example, the CO attached with 4 carbon. 4, you write down 4 carbon. 1, 2, 3, and 4. Okay, then afterward, we attach with CH3, CH2, CH2. Stand by, and followed by amide CO. Okay, followed by N here. However, the chemical structure stated there, it should be N-cyclohexyl. Cyclohexyl, hex 6 carbon. So we attach to here. No more, we attach with H. For temporarily, we do a check. Okay, then the question also stated N and 3 diiodo. Then we mean this N is not H. It should be iodine. Carbon number 3 with the iodo, then we're having 1, 2, 3. Here's carbon number 3. Then no H, but it attached to I. So this is the answer you have to rewrite. Rewrite properly. So CH3, C with the I, H. C with the H, then followed by CO. Done. And attached with iodine, followed by benzene ring. Not benzene ring, cyclohexyl. So this is a chemical structure. If correct, give 2 marks. Okay, Sivendran, you are number 6. So check your answer, but no model mark for you. Okay, done already? Any question you want to ask so far? Okay, conclusion, you must very familiar about the common chemical structure for each functional group. You must familiar. Okay, when talking about anhydride, you know already, this is the formula for anhydride. When I call about the acid halide should be RCOX. So you attach to CO, X is referred to bromine, chlorine, iodine, fluorine. Then attached with the R. R can be anything. R can be cyclopentene or whatever. Okay, be careful. And followed by when talking about amide, you have to know refer to the molecular formula RCO followed by NH2. Very, very common formula. Then you attach for those the substituents into the chemical structure. Boleh faham? Okay, done already. Thank you for those. Okay, check your answer and later report to me your mark. Doesn't matter. I want to know about your performance. Can? Okay, now my turn. I show to you the chemical structure. What can I do? Now I know I refer to, they got 1, they got 2, they got 3, they got 4. So 4 compound, then we know this refer to bute. Bute, all single bond, butane. Okay, and the functional group, circle, we got NH2, we got OH, we got benzene ring. Be careful. NH2, OH, and benzene ring, priority is referred to NH2. So you must refer to amine group. Amine group. So buta, which amine? Butane refer to the carbon which is 1, 2. 2 amine. Okay, you want to put, you put 2 butane amine also will be accepted. Okay, because amine group. OH group is a lesser priority. Cannot put alcohol. We put the name as a hydroxy. Hydroxy. Then followed by here we got phenyl. Which carbon? Carbon number 1. So we got 1 hydroxy, 1 phenyl. Okay. Now which one is your priority? H first, followed by P. So chemical name we give 1 hydroxy, 1 phenyl. Okay. You put 2 also can butane amine. Can build 4 carbon and single bond. Amine refer to NH2 located at carbon number 2. Okay, you put here number 2 also can will be accepted. Done. Okay, now we go further. Okay, this chemical structure, you don't know, you put H. Now we know this one refer to what? Yes, it refer to aldehyde. This one also aldehyde. But aldehyde should be the priority, must give the lesser number. Carbon number 1, number 2, and number 3. Here refer to the substituents group. How many carbon? 3 carbon. We call propyl group. Propyl. Okay, now we make it all together, which is 1, 2, 3, prop. Single bond, propane. Okay, then carbon number 1 and carbon number 3, okay, which is located for dial. Okay. So normally aldehyde is a terminal group. We won't give any number. You just put propane followed by dial. Okay, dial. Okay, But some students, they say, Mr. Lim, if let's say I put propane 1,3-diol, can or cannot? Will be accepted. Will be accepted. Okay, 1,3 and followed by propyl, carbon number 2. So we put the name true propyl. So rewrite the answer. 2-propyl propane 1,3-diol. So this is the answer. Can Can. Okay. Next one, number 3. Yes, cyclo. Cyclo what? We write down first. Cyclohex. Hex, we got 2 alkene group. So cyclohex, hex something first. We have to put diene. Hex, diene. Okay, which diene? You have to understand. We got diene. You have to put A here. Hexadiene. A attach. Okay, which one should be carbon number 1? Br compared to diene. Diene should be the first priority. So we got 1, 2, 3, 4, and 5. 6 here. Reversely, 1, 2, and 3. So you can see both sides will be considered the same. Carbon number 1 and carbon number 4 attached with diene. So 1, 4, diene. Okay, carbon number 3 and carbon number 6, we got bromo, we got methyl group. Okay, so 3 with the bromo, 6 with the methyl group. Methyl group. B first, followed by M. So we have to attach the name, which is 3-bromo, 6-methyl, followed by cyclohexa 1,4-diene. Hey, don't be careless. They got this symbol. This symbol show to use under the cis conformation. So finally, we give the name as here. Cis 3-bromo, 6-methyl, cyclohexa 1,4-diene. So this is the name for the chemical structure. Refer, be careful, hyphen using for the alphabetical and numerical. You must know how to put it correctly, followed by the A must be attached because of diene. Okay. I'm sure that students sometimes will ask me, Mr. Lim, 1, 2, 3, 3-methyl cannot match. Since we having the equivalent 1, 2, 3, 3-bromo and 3-methyl, which one we choose the priority? Should we ever do, because they are under the same locations, so we based on the alphabetical. One is a methyl, one is a bromo, B, we have to make it lower case. Understand? So we call it as a 3-bromo instead of 6-bromo. Cannot be. Clear? Clear. Okay. So this is the chemical structure. And now it's your turn to answer. Have you ready? Okay, come. Here is the answer questions. Come. Do for me and tell me your answer. Come. You need some hints? Okay, I give hints. Okay, so first thing, same thing that we know. This one refer to cyclohexa diene. Clear? Okay, then afterward, this one refer to the compound that we have. I put a H here. Then circle this one. Then followed by, here they give it to you the chemical structure, which is RCOOR. And this one refer to the hydroxyl part. And this one refer to the carboxyl carboxylic part. I give hints already. I wish that you can answer it. For question number 2 first. Number 2 that we know refer to aldehyde, because aldehyde give it to you carbon number 1, number 2, number 3, number 4, and number 5 over here. Okay, so we know refer to pen. Pen something. Pen, we got pen diol. Diol, which is 1 and 5. 1, 5. Don't forget, we got alkene group. Which alkene refer to here? 1, 2, 3, 4, 5. 1, 2, 2 pen, 2 in. So this is carbon number 1. Carbon 1, okay. Carbon 1 with alkene group. So pen, 2 in. Get it? Okay. Since we got diol, so you have to keep the E here. That's how I show you the answer correct or not. Remember to keep the E, don't erase it. Then afterward, we got here, we call benzyl. Not phenyl, benzyl. We got benzene ring with the CH2, we call benzyl. Okay, so the answer which is 1, 2, 3. 3. Three benzyl, pen 2 in, 1, 5 diol. Check your answer. Any of the single mistake also consider wrong. You must give it correctly. Okay, then question number 3. Hydroxyl, we got 1, 2, 2 carbon, ethyl. And here carbon number 1, carbon number 2 is of here, we attach with chloro. Chloro, so it should be 1 chloro. 1 chloroethyl for alkyl group. And this one give to you under carbon 1, 2, 3, and 4. 4 spacing but. All single bond, butane. Okay, butane. And you have to know this ester, we have to end by OATE. OATE. Cancel the E and connect it over here. Carbon number 1 and 2, we got hydroxy. So should be 2 hydroxy. So now we combine together, the answer become 1 chloro ethyl. Okay, followed by 2 hydroxy and bute. Butane, OATE. Okay, alright. Okay, now we go to question number 1. Question number 1, we have to go to parity, which is the double bond should be the lesser number as possible. So this is 1, this is 2, this is 3, and this is 4. Okay, or this is 1, 2, 3, and 4. So we have to know about to give the number as smaller as possible for the alkyl group over here. Okay, okay, so you can give the number which is 2, 2 here, carbon number 2, 1, 2, 2 here, 2, 3, 4, 5, 6, 5 and 6. Okay, rather than you turn another around, which is 1, 2, 3, 3, 4, 5, and 6. So total up, you can see the difference. This one equal to 13. This one equal to 14. So we know this is carbon number 2 with a 2 methyl group. Yeah, 1, 2, 3, 4, 5. 5 also methyl. 6 also methyl. We got totally 3 methyl group. Okay, so we have to give the name cyclohexahexa what? hexyl 1, 3 diene. Then followed by the substituent group, which is 2, 5, 6 trimethyl. Okay, so combine together the chemical structure name called 2, 5, 6 trimethyl cyclohexyl 1, 3 diene. Okay, if you correctly, give yourself 2 marks each.
Mr. Lim.
Yes.
For the first question, got trans, is it?
Got trans. Thank you. Okay, for you to remind, we got 5 and 6 show to us under the trans. Okay, thank you. So we have to put the name trans 256. Thank you. Yeah, one student just now give me the answer under cis. Wrong already. You must know about the difference between cis and trans. So for your information, listen, in your answer booklet, what they got when you open it like a book, they got middle line and the left and right sides. Left side totally blank, no line, no line. Okay, and which you can do any rough answer on the left. You write on pencil or pen, whatever, not counted as an answer. We ignore it. Please remember, class, don't make mistake. You write your actual answer on the left, consider no mark. You say, I do know. Right? We tell you, I also do know, because this is under the regulations. Okay, so your answer should be written correctly on the right with the line there. You must write properly and give some spaces when you answer it. Understand? If let's say the answer cannot finish, then you can turn to another page, also on the right side to continue. Don't answer for both sides. You answer for both sides, when you have the answer correctly, even those on the left, we make it wrong or maybe no mark. Clear? Very serious on here, because students sometimes they still blur. They think about all answer can be written from both sides. So at the end, they come out all the answer on the left, or we cannot mark. Finally, the student field for organic chemistry. Clear? Clear. Okay, now we proceed. Can we? Draw the isomerism for the compound and mark N3. Then, if let's say you come up with this answer, don't be panic. You what to do? Quickly expand the chemical structure. Okay, so we refer to here the carbon with the CH3, then followed by C. We got 2Cl, followed by CH and the Br. Continue by C and the CH3 to got 2. Followed by CH2 plus 1 OH. If you explain correctly, then you have a first step successful. But remember, 5 mark, you must know about the stereoisomer should be under 2 isomers structure drawing. So you have to identify which one should be the chiral carbon. C with the H cannot be. C with the 2Cl cannot be. C with H, Br, carefully, and they got big R here, another big R group here. So we can able to see this is the chiral. We suspend, we check the rest. C with 2CH3 out, cannot be, C with the H, you can see the 2H already, don't think about it. Just let it go. And now you know already this is the chiral carbon, and we can able to draw 2 structure like a mirror. So once again, I draw. I get ready, I won't be bending. For group attach. Okay, now I put it up to me how I decide. For example, I put the difficulty of the top here. Top C, CH3, bracket, put 2, followed by CH2, OH. Okay, at the top here, you no need to reflect because they are keep rotating. Whatever you write are the same. Is it clear? Clear. Okay, done already. Now I refer to this part. CCH2, Cl, then followed by CH3. I put it here. CCl2, then followed by CH3. Reflect. CCl2, CH3. And followed by H, and followed by Br. Don't do funny thing. This Br, when you reflect, don't put here and tell you when we mark, we laugh until we don't know. We are shared among our lecturer. Then finally, we just keep. Do not know how to comment on the student answer. Okay, don't make funny things to us. And strict. And how we mark? Normally, yes, I will check. Is it the student draw the structure in a tetrahedral? Yes, 1 mark. Then after that, we check. Is it the carbon shown to us under and strict? It means the student choose correct the chiral carbon. Clear? Okay, then afterward we check. Is it all the structure draw under the correct sequence? Then the sequences of the chemical structure. Then is it the chemical structure draw in pair? Yes, okay. Finally, we do a check. Is it the student can show that it's under the mirror? Mirror reflect correctly. So, for example, CCH2, Cl2 by CH3. How about we reflect on the right? Correct? So, that means the orientation. Totally 5 marks. And then this question we see sure should be come up with 2 chemical structure. Cannot be 1. Can Okay. Arvin, print screen, thank you. Are you ready? Yes, okay. Now I give to you 1 question to answer. Ready? 1, 2, 3. Answer for me this part. Arvin, have you print screen?
Done, sir.
Done, thank you. Okay, now I write the answer. Okay, here's a chemical question. Come, do it now. No idea how to draw. Okay, I give it to you hints. The chiral carbon, which is, okay, we check. CH2 cannot be. CH with a double bond cannot be. Here cannot be. COH2 also cannot be. Here cannot. Here also cannot. Then which one should be the chiral carbon? Where? Check for the rest. Here cannot because all consider CH2. Here also cannot. The one chiral carbon which is here. Here. I give you hints. Okay. The hints that we're going to draw, which is here they got one more attached with H. So we can draw like this. Okay, I give you hints already. So how to answer up to you. Come. Oh, very fast. Yunyang draw already. Sorry. Because Junyang, the question stated there chiral center. So chiral center cannot be cannot be cis or trans. Cannot be. Cis and trans should be referred to the another side, which is under the geometrical isomers. So your answer, sorry, reject. You put at the top there. Okay, let me do a check. Correct or wrong? Junyang, your answer I have to minus 1 mark. Which answer should be, Junyang? Top or the bottom? Which answer you want to show me?
Hello, sir.
Yeah, which answer should be? Top or bottom?
The question not asked for the stereoisomer. I thought that geometric isomer also be the one of the stereoisomer.
Okay, be careful. Even though it's not it give it to you possible stereoisomers. Let me check. They got chiral center. Okay, chiral. Okay, and you have to be careful, which is listen, listen, class. Can you have a listen carefully? In your syllabus, I repeat, in your syllabus, you know that stereoisomer can be either under we call geometrically or optically. Geometrically, which is cis or trans. Optically, it should refer to the chiral center. Yeah, okay. In the geometrical, cis and trans refer to just only one double bond. In your syllabus, cannot be two double bonds. When you come up with two double bonds, it's under degree program already. It cannot be counted in your syllabus. Is it clear? Clear? Okay. Then afterwards, you refer to the another side. Optically, so we know must find out where is the chiral center should be. Is it clear? Clear? When you come up with two of the double bond here, then you know already this is not under your syllabus. It's just only one double bond. Okay, because this question will come out another curious, student will keep going to ask which of the chemical structure should be drawn. Since they got two of the double bond, so they can come up with 4 different answers. 4 different answers plus chiral carbon is totally 6 answers to draw. It's not under your syllabus. It's not under your answer skip. Because normally in this question, we just located for around 3 minutes to let the student to draw. 6 chemical structure is spent around 10 minutes already, which is not under the scope of your learning outcome. Understand? Okay, please understand. So we just only refer to one single answer. And Junyang, you have to know about the orientation for the solid and also the dash wedges that you use. Which one should be front, which one should be at the back. You cannot put simply. You put simply, we don't know how to mark it. That's how you draw different way. Okay, Junyang, resubmit your answer. I give you one more chance. Okay, now refer to second answer from Puhin. Puhin, Puhin, sorry, chemical structure cannot be accepted. I give to you 5 bonus mark only. Answer wrong. Puhin. Okay, one more student answer, then I'll show you the answer. Answer from Pujay. Pujay also 5 mark. Answer's wrong. Okay, now I show you the answer. This is the answer. Hey, have a look. Can you put out your pen? Same this chiral carbon, when you draw it, just only copy the whole part here. Put carbon. Come with the wedges. Yeah, okay. Then with the middle line. What can you do? Yes, just follow the chemical structure. Okay, then come up with okay. Here. Yeah, go for another way. Here. Clear? Okay, this is the chemical structure. Don't open up. Why you come up with the CH2, CH3 and so on? We just copy the whole thing into it, change for all the color carbon and done. Understand? Okay. Okay, if you can able to find the correctly for the carbon, give yourself 1 mark. Okay, the chemical structure you draw wrongly, let me check. Wait, you're able to find the correctly for the carbon, strictly give yourself 2 marks. Okay, the chemical structure you draw wrongly, nothing to do. You just only strictly give 2 marks for what? For the correct chiral carbon and followed by the N strict that you put. Clear? Clear? Okay. Shall we proceed? 10. Okay, now we go for question number D. Okay, can we have a look? When the question come out already, normally I refer to the chemical formula over here. Draw 2 possible pair. 2 possible pair, that means 2 times 2 equal to 4. You need to draw 4 chemical structure. Structure which is given to you under cyclic compound. Cyclic under geometrical. So you must fulfill which is must have a cyclic, must have an under geometrical. Understand? Cis or trans. So if let's say you just only concerned about cyclic, you didn't show geometry, out. You draw geometrical isomer, but without the cyclic, also out. Because students do know how to understand the questions. Okay, for me, what to do? I refer to the carbon number and the hydrogen. If let's say it's a C5, H8, C5, H10, C5, H12. 3 conditions. Okay. C5H12, I know that this one refer to long carbon chain with all single bond. All single bonds. Okay, here aliphatic. Yeah. But when I come up with C5H10, I know that it must be referred to what? Yes. This compound must be must be a carbon compound with 1 double bond. Okay, double bond or is under a cycloalkane compound. Here. It means it must be CC double bond or it must be a cyclic form. Okay, or C5H8 already, I know that mostly this compound must be because to fulfill the formula CnH2n minus 2. I know that this compound must be containing 1 double bond and I put N and cyclic, under a cyclic compound. Okay, so from here that I refer to the chemical structure that I have. Yes, C5H8, I know that it should be a double bond and followed by cycloalkane. Okay, so O2 here that you can able to know, this one should be under a ester. Understand? Okay, done already. You have a rough idea. Okay, it's stated there cyclic, that I know I can put C5 here become. Can you use all cyclo and followed by COO here? Yes, okay, let me do a check. Hey, CO, COO. Hey, what I'm drawing here. Guys, have a look. Come, pay attention. CO, then I can make a formula which is C5H8O2. I minus here, which is how many? C6. 5 carbon with a 6 here, then this chemical structure consider out. Cannot be. So if let's say I draw like this with the COO. Yeah, I put here is a CH3. Cannot be. 7 already. Cannot be. Here also cannot be. Because of why? They give to you wrong. It should be under how many carbon? 6 carbon over here. This one. So this is considered wrong already. Then your mind should be turned around. Why? Because we have to base on here the carbon here. The carbon should be lesser number to form cyclic. How to make? Yes, I choose cyclopropane. 3 carbon only, Right or not? Then afterwards, I know it's under geometry. I must draw the cis and the trans conformation, like here. Yeah, okay. Then afterwards, I can apply anything that I want to eat. First, cyclic. Secondly, must be have a double bond. Then what should I do? I put COO here. Okay, how many carbon that I use? 1, 2, 3, 4. Then follow by 5. Can Can, okay. Be careful, I say be careful, because of why? You have to know how to attach correctly for the carbon that you have. I put H. Can I put H here? Cannot be, because this under the cis conformations and trans conformation, just only H and H can be used, but this 2H cannot show with the one more H attached as a geometrical isomerism. Cannot be. So what should I do? Quickly think about, must put the H the same. This H must be changed. What should we change? Change become CH3. From where the CH3 come? Here. Yeah, so when I come out here, the H swap, and I will able to form this chemical structure. COOH. We got H followed by CH3. Can okay, now you can do a check. How many carbon I have? 3, 4, 5. 5 carbon. How many O? 2 O. How many H I have? Check. 1, 2, 3, 4, 5, 6, 7, 8. I know that 8 hydrogen. Is it fulfill all? Yes, I know that this chemical structure correct. I draw, and I can able to suggest another pair. Another pair which is, this is under the cis. Then how to convert become trans? That I can able to show the changing between one of the group. I change the H, CH3. The right side remain. Understand? Okay, here's a trans, because with the H under the trans conformation. Is it clear? Clear. Okay, so be careful. Some students, sometimes they draw a incomplete form. They draw C with the O here. What is a COO here? Cannot be. Impossible with a COO with here we go O, just only with single bond. It must be attached with H or maybe CH3. Cannot be O single. Cannot be. Totally wrong. Enough? Okay, then afterwards, how you able to show further? Student say, Mr. Lim, I know that CO ester cannot be anymore. So can I make it become aldehyde? I say, why not? Aldehyde, that means this OH, I change become H, and this side I put O here. Okay, so it become a new compound like this. OH, COH, followed by CH3 and H. Yes, from just now the carboxyl, then it become aldehyde. Then here give it to you the different OH. Okay, be careful. I say be careful. Why be careful? Is it can able to show you the formations for it? Cannot be because of why? H to the H here cannot form already. Cannot form already. Then what should you do? Student is say, Mr. Lim, I know already. I put O here, then this one I convert it to another side and make it become OH. Okay, sorry, OH group. Here I use with just only H. Is it possible? I rewrite the chemical structure like here. AH. Okay, I put OH. I put OH, then followed by CH3, followed by H. Can or cannot? Can or cannot? I say be careful. When you draw it, you must be careful for it. Some students say, Mr. Lim, can why not? Hey, be careful how many carbon that you have. 1, 2, 3, 4. 4 only, but we need 5. Then how? How are you able to make it? We know that we can able to convert it, become another way. How the way? Yes, I put a double bond over here internally, internally, so I can able to show under the cis strand conformation. But be careful, when going for the cis strand, all should be under a single bond. Cannot be attached with double bond on it. Cannot be. So you have to think about it. If let's say this question is very tough for you to do, you spend around 2 minutes, you still cannot come up with another pair, quickly leave it there. Go to another questions. Understand? Is it understand? Can I be careful? Don't stick on here to spend so much, because each question normally will contribute 2 marks and 2 marks. You spend more than 3 minutes to solve, then quickly you better quick and go for another questions. Otherwise, you cannot finish. Because of what? 4 more months. You spend too much of time on it. It doesn't work. Clear? Clear? Okay, now you have this idea. Print screen, thank you. I give you another chance. Tell me another pair of the chemical structure. Can? Okay, later, check answer with me. Okay, now I give to you one. Okay, let me do together. I give you hints. Draw 2 possible structural isomers. So, doesn't mean that geometrical or optically, no, but it containing 4 carbon ring with the molecular formula C5H5N. So this chemical structure must be drawn in the cyclic form. So how to do? First thing, we have to know how many carbon should be. 5 carbon, isn't it? 5 carbon, I can able to draw 5 carbon. Then followed by N here. How should I put the N? N, what do you think about it? Students say, Mr. Lim, it should be amine group. I say, yes, can be. Mr. Lim, if let's say it become amine group. I say, amine, are you sure? Are you sure? Because amine group should be R, C, O, and H2. any O. No O cannot be amine. Amine can. And another one should be nitrile group. What's the nitrile about? C triple bond N here. Can? Can. Okay. Now you see C5H5N, you spend all in the cyclic. Is it possible? Cannot be. You have to know one more carbon attached to the nitrile. You must reduce the number of the cyclic. Then we put C followed by N here. Then do a check quickly. Is it 5 carbon? 5 carbon. How many hydrogen? We got 1, 2, 3, 4, 5, 6, and 7 over here. Yeah, 7. We need just only 5. Is it? Cannot be. Then what should we do? Quickly that I put the double bond into it. Now count the number. Is it 1, 2, 3, 4, 5? Yes. 5 carbon, 5 hydrogen with 1 N. Yes, this is one of the answer. Can I? Okay. Amine group. Amine group, what can I do? Yes, I put N here, then attach with the carbon that we have. 5 carbon, up to me to put, I put here. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, then with the H that I have, be careful, put double bond first. So I can reduce the number of H. 1, 2, 3, 4, 5, 6, 7. Is it can be accepted? Can or cannot? Tak boleh. Why cannot? Because the question stated there 4 carbon rings. Understand? Okay, so in an aliphatic, cannot be any more. Can? Understand? Okay, then what should I do? So I know that I should refer to this question back. In here, the double bond attached, then I can draw another one. I draw like this. Okay, then I ask the student, do you think that your answer is correct? Mr. Lim, correct ma? The double bond, different positions. I say, do you able to give the name for the double bond? This is carbon number 1, carbon number 2 with the double bond. This is carbon number 1, carbon number 2 over here. So these two consider same. Same chemical structure. Then what should you do? Smart student say, I know already, Mr. Lim. I attach the double bond with the CN here. Now from carbon number 2 with the double bond, I put carbon number 1. I say, can, no problem. Then you attach with the H chemical structure. And count the number. Is it correct? Yes, correct. So that means we have 2 answers to draw. Is it clear? Clear? Get it? Get okay. Now I give you 1 question to answer. Have you ready? Cannot be like here, cannot be. You must involve 2 carbon to show the cis and or the trans conformation here. Okay, this way? No, sorry. Okay? So the rest of the chemical structure is up to you. So for example, C5H10O2, you must concern about, is it you can able to use all the carbon, hydrogen, and oxygen in your molecular structure. If you do count number by yourself, yes, then we go to second one. Second one, is it you can able to show us the conformation of cis or under the trans? They say yes, then we give to you correct. Student put wrongly for 5 carbon become 4 carbon. Overall, totally out. We put 0 mark for the structure. Okay, because students still do know how to utilize all the atoms in the molecular formula. Okay, next one. Check properly. Is it under a pair, under the cis and strand? Yes, then we give to you 2 marks times 2, 4 marks each. Smart student, you know about this under C5, they can able to show under the cyclobutane. Then afterward, they use the H to identify it under the strand or cis conformation. Then the rest, they put CH3, OH and OH, then followed by H. Oh, okay, no problem, because I'm not limited for you to do any chemical structure for the function group, etc. Okay, mark yourself, your answer. Okay, now we take a break for 5 minutes, then we proceed to question number 2. Okay? Okay, I see you 11:50. And when you take a break, you can prepare to get some food first. For example, your lunch or whatever along with you. So you can having the same way with your meal together with the discussion. Okay, we quickly finish all question 1 and 2. Then tomorrow we proceed to question number 3 and 4. Okay, class. Shall we proceed? Okay, I wish that you can able to know to score the question number 1 already. Okay, remember in the isomers, if let's say you're scared to draw it, you spend around 1 to 2 minutes, rough out the answer. If let's say cannot, leave it there. Don't spend too much of time. Proceed to the following question that is easy for you to answer. Do you understand? Don't spend more than 10 minutes with one question. I tell you, you really will lose a lot of time when you answer it. Okay? Now we proceed to question number 2. Okay, so question number 2 is about the properties. The question normally will ask you about the acidity, basicity, differentiate, and followed by the chemical equation writing. And this all under the property itself. Okay, please have a look. Okay, quickly do a check. What case? There were 2 different cases. Compare the basic strength. Basic strength, then quickly that we know this one refer to the amine compound. So the amine compound that you should refer to here, this one. Yeah, so quickly we call whatever that we know. Yes, when the amine group attached with 1, 2, 3, 1 only, then we got 1 Cl, you must know about what is the difference. You can see the question quite similar. You just only have to know about how you answer it based on your own idea. First one, we know is under alkyl group, EDG, electron donating group. Meanwhile, for those the Cl under EWG, you have to mention it because it containing 7 marks, each of them. Okay, now we know that refer to this case. At the top is under acidity. Bottom here is under the basicity. Then you see, yes, let's say it's under alkyl group. We know that this is under the EDG group, electron donating group. Electron donating group will undergoing to increase the electron density on what? On nitrogen atom. I give keyword, you can make your own sentence. And cause of the higher electron density, so it's easily for N to form what? To form dative bond. From where? With H plus from water. Yeah, okay, from water. So this one actually to tell you the increases for the dissociation of water to form what? To form OH negative ion. Yeah, OH. So that's why the basicity of the solution consider increases. Understand? You done already, be careful. You mentioned just only one side, half mark only for you, 3.5. You might mention about the Cl also. So the Cl group is under electron withdrawing group, which is to withdraw the electron toward it. Electron drawing. So the electron density of the N will be reduced, and it's difficult for N to form dative bond. Okay, dative bonds. So that's why from where? From water. That's why the dissociation of water will be considered reduced, and this one will make it the basicity getting reduced. Understand about the way? Okay, so now I want you in the following part answer for me using this all the keyword. Yeah, okay. This one for basicity. If let's say under acidity, for example, this one. Hey, have a look. So you also have to go to the same way, but this time you go to the acidity case, which is here. Electron donating group. Which one? Case number 3. Okay, which is undergoing to increase the electron density of oxygen atom. So they make it the strength of the OH group getting directly, which is increases. And this one to make it the removing for the H getting more easier. Strength getting higher on the O, but the dissociation is reversely, which is easy to remove the H plus. Okay, and as a result, this one able to make the acidity getting higher. Okay, let me do a check. Oh, sorry, my mistake. Okay, so once again, this one to make the strength getting higher and to make the removing for the H plus getting difficult, and to make the acidity getting lower. Clear? Okay, reversely for those under VR group, which is under EWG. So you have to know about the sequence to give the keywords. Okay, are we? Print screen, thank you. Class? Now it's a turn for you to explain to me using these keywords. Can? Okay. Try to answer for me this. Here. Okay. Compound 1 is more acid than compound 2. Okay, compound 1 is more acid than compound 2. You might give it to me this statement. So I give to you 1 mark. Okay, then you can discuss. Talking about compound 1. Why? Compound 1, we got NO2 and the benzene. They are what? They are EWG, electron withdrawing group. Okay, so when you come up with the EWG, then what point? Yes, pull electron. Pull electron from where? From O atoms. Here. Okay, NO2, NO2, they are EWG, and afterward we just focus on NO2. Because of why? Benzene ring having two-sided, but you must mention about it also consider electron withdrawing group. NO2. Okay, then afterward it's under EWG, pull electron. This one we make about the electron density getting what? Getting reduced. Okay, then afterward to make the bond strength, between O and H getting what? Weaker. Okay, so it's easy for what? It's easy or easier to donate or to release H plus. H plus is ion, not atom, ion. So this one to make it the acidity increase. Okay, then afterward you go to compound 2. Compound 2 that we got benzene, which is under EWG, but you put bar, but we got CH3 is under EDG group. For those EDG group, they will what? They will push or donate electron to all atoms. That's why they make it the electron density getting higher. And to make it the bond strength between the O and H getting stronger and difficult to release H plus. So that's why the acidity is getting lower or decreases. Get it? Okay, so you must mention about 2 different cases in one statement. Am I talking about dative? No, dative for those amine compound. Here under acidity, when talking about acidity, should be alcohol or carboxylic acid. Okay, Puhin, you make wrongly already. You go to another way there. Sorry, 9 mark we just give to you 2 mark. Which mark? Here, EWG and EDG. The rest, sorry, wrong already. Okay, if you say you can able to answer correctly, 9 mark. But be careful with the benzene, because you didn't mention about benzene, you have to deduct 1 mark or half mark. Can. Okay, one more trial for you. Here, anything? Let me check. Oh, no more already. Okay, print screen. Thank you, Arvin. Sure, during your final examination, this question will come out. Either it's under alcohol carboxylic acid to ask about acidity, or amine group to talking about basicity. 100%, either one. Can? Okay, if let's say can, I wish that you can answer it. Arvin, have you print screen?
Done, sir.
Already, now we go for our this part. To identify the boiling point. Once again, this question will ask you again according to the ascending order based on what we have. What you're going to discuss? Yes, first thing, this compound. We got alcohol, we got aldehyde, then we got alkene group. Okay, so we know this is under the OH group. Okay, you can put alcohol or you can put hydroxyl. Aldehyde is under, what is a functional group? Yes, it's under carbonyl. Then it's under alkene. Okay, then afterwards, you have to know about the difference of the functional group here. There were different type of the intermolecular forces. Since we got alcohol, so it must involve hydrogen bonding. Carbonyl group, PDPDF. Alkene group is under van der Waals. You talk about it, then further you have to tell about their bond strength. Bond strength, which one having to use the most higher bond strength? Yes, hydrogen bonding. Here. Then compare to the PDPDF. Then go to the van der Waals. Okay, bond strength, and afterward you're talking about the bond energy. Bond energy also the same way, which is hydroxyl have a bond energy higher than PDPDF, higher than van der Waals. As a result, the boiling point also under the same pattern or the same order. Get it? Okay, so this all the thing that actually is based on how you describe it, based on the idea that you have. As a lecturer, normally we mark where? We'll mark here. Student can identify each of here. Hydroxyl, carbonyl, alkene, they got 3 marks already. Yeah, then hydrogen, PDPDF, with the wall under the same mark, which is half of them. So this all the two will contribute to become 1 mark. Then afterward, the student can arrange bond strength correctly in the first order. Correct. Then bond energy correct. Then boiling point also correct. Then total 6 mark. Understand? Okay, you can see the pattern all the same. You just only have to know about the sequence when you answer it. Still cannot. Okay lah. Okay, so firstly, I have to mention about okay, they are alcohol or hydroxyl. Okay, I talk slowly. Then afterward, this is under aldehyde. Aldehyde should be carbonyl. You put this on aldehyde, also will be accepted. Yeah, okay. Alkene group. Accepted here. Then you have to involve the type of the intermolecular bonding. Hydroxyl, hydrogen bonding. Carbonyls is under permanent dipole forces. Okay, go to chapter number 2, physical chemistry, you can know about the name. Alkene group is under van der Waals forces. Done already, then you can able to tell about the bond strength. Bond strength, which is van der Waals the lowest. PDPDF, then followed by hydrogen bonding should be the highest. Bond strength, then go to the bond energy. Also the same way. And then go to the boiling point. Also undergoing the arrangement, because the bond strength and bond energy directly proportional to the bond and to the boiling point. Okay, right? Avin, can you print screen for this? Okay, so remember, you remember about the statement, or every question you can answer, but don't bring any paper, a piece of paper during examination hall. When you've been caught totally out, you under suspending for 1 semester. Then you have to repeat this course, organic chemistry. Yeah, don't take a risk. We will observe because we apply apps on each of the students. Okay, you don't know how to do it because we have the system. We don't want to tell you. Be careful. Okay, now can you give me the keywords of this following question? Can you able to answer and tell me? Okay, this question. Okay, come, open for you to answer. I want the keyword. Okay, let me do a check. From here, butanoic acid is the highest. So should be 163.5 degrees Celsius. Okay, meanwhile, butane the lowest, -1. Butanol, second. Okay, done. Okay, and explain your answer in a term of intermolecular forces that we know. Now you have to give to us is under ascending order. Okay, you can write down which is butanol. Okay, you put extra knowledge also can. You put that is under hydroxyl. Hydroxyl, then should be hydrogen bonding. Then how about butane? Butane from alkane, alkane. Which is, be careful, this is not PDF, no. Butane group is just only having is a van der Waals. PDF is just only doing for benzene compound and also carbonyl. Not for butane. Butane, van der Waals. Afterward, we go to butanoic acid. Butanoic acid under carboxyl, which is able to form dimer. You done already, then you can proceed to the bond strength. And go to the bond energy. Okay, bond strength and bond energy. Okay, so which one is considered the highest? Yes, dimer. Hydrogen bonding. Van der Waals forces. Then that's why they need higher energy by the sequence of van der Waals, hydrogen bonding, followed by dimer. Okay. Compare the explained solubility of butanoic acid and butanol in water. So you have to know about the difference. Let's say it's under alcohol, ROH. You connected to the O and the H with water. This is we call hydrogen bonding. Okay, with water. Apa ini? Look here, with water, it's just only one hydrogen bonding can be formed. But in carboxylic acid, it's a different story. Why? Because they can able to form not only one, but two hydrogen bonding, number 1 and number 2. Okay, with water. So that's why in the way that you can see that one molecule is very important for you to form the bonding with water. So you write for you. Okay, with water with a H2O. Okay, they got bonding hydrogen, number 1, bonding hydrogen for number 2. Okay, as a result, in question number 3 here, you must state that which is butanoic acid. They can able to form what? To form 2 hydrogen bonding with water. With water molecules. Okay. However, butanol, it just only can form what? Can form just only 1 hydrogen bonding with water. With water molecules. Then how about the solubility? Yes, as a result, butanoic acid, which is having higher solubility with water rather than butanol. Understand? Because this only can form 1 hydrogen bonding with water. So here give to you 4 marks. 1 mark here, 1 mark here, 2 marks here. Okay, we are not talking about the alkyl part will become the predominate for the carboxylic acid because it is under individual case. But this one is under comparison between 2 cases. You must know how is it. And okay, RV, print screen, thank you.
Done, sir.
Oh, thank you. Okay, Travis, yeah, I can check your answer later. Shall we proceed? Yes, we go to our last part today. Okay, last part is how you're able to identify between the two. Suggest suitable reagents, conditions, and the difference between butamide and butamine group. State the observation and provide chemical equation for the reactions. So now you do a check. Butamide here. This is butamide. Butamine here. You draw a chemical structure, then quickly you try to recall. What is a functional group? Yes, amide group, and followed by NH2. Then what you're going to do? Yes, you can do a check from which part? Easy. I did call you before. I say in the primary amine, it's just only one test we can run through it, which is HNO2, nitrous acid here. So how is it? They can able to show you the formation of gas bubble. Gas bubble, and furthermore, undergoing for the chemical reactions, this under observation observation. Okay, the chemical equation, which is amine group is undergoing to form NO2 as a gas plus carboxylic acid. And plus one more thing, what is it? Can you tell me? Yes, water. Okay, this is under amine group. Hey, how about here? is it able to form any new items? So we can able to obtain HCl. HCl. So how the HCl going to take part? So NH2 that we can able to do it or not? So you can suggest more suitable way. Okay, so for me, I'm using HNO2 test. Amine, primary amine going to obtain gas bubble. These are the chemical equations. And for here, nothing happen. Nothing happens. You have to write properly for those amine group. This one for amine. And for those no gas bubble observed, is under amine group. So equation, no. Is it clear? Clear? Okay. Condition. In using nitric acid, you under room temperature. No need to apply any heat. We just only pour into it to observe any bubble release. That's all. Okay, RV, print screen, thank you. Class? Okay, now we proceed to our following question. Can you answer for me here? D, we got 1 and we got 2. So tell me what type of the reagent can be used. So what you're going to do, first draw the chemical structure correctly, identify the functional group, and recall what type of the reagent can be used to identify them. Okay, you don't know how the structure look like, I draw for you. Phenylamine here. 1-phenylethylamine. Okay, what you're going to do by the chemical structure drawing here, you have to tell me what is the test can be used to identify them. Okay, class, do it now. List down and send it to me WhatsApp. Then I'll tell you the answer. I just want to know about the test. Hey, I listed already here. So many items you can choose. No answer. Okay, never mind. You start first. So this is under aniline. Aniline that we know we can choose. Yes, we can choose Br2 water. Which one? This one. Okay, be careful. Okay, it's totally different because under the reaction itself, we can able to obtain a new compound. What's a new compound? Yes, this new compound can be obtained. Yeah. Okay, what is it? Yes, this one able to show you the white precipitate is formed. This one refer to this compound. I make a short form, you do by yourself. Okay, how about this compound? This compound, sorry, they cannot able to obtain any compound. Can? Okay, another student say, Mr. Lim, this is under a primary, it is under a secondary type. Secondary type and mean. So, can we use nitrous acid? The answer is tak boleh. Cannot. Because this C attached with 1 and 2 alkyl group under secondary. Secondary cannot use nitrous acid to identify. So, cannot. Both also cannot use to obtain a negative and a positive result. Be careful, this is NH2. It's not considered primary and mean. I repeat, not, because it's under aniline series. That means the functional group should go to our benzene ring. So in case that you are still using nitrous acid, they still give to you a negative result. Negative result, nothing gas will be obtained. Understand or not? So just only one, we use bromine water, chemical equation, and the observations. Condition, room temperature. Can, okay, done already. Let's say you choose correct, give yourself 3 marks. Okay, now we go to another one. Another one, students say, Mr. Lim, this is ketone and this OH group. Can I use ester to form it? Ester. Esterification. You come up with a sweety smell. Cannot. I say OH can, but how about OH here? You give positive result also. So ester, tak boleh. Cannot be. Then they say, Mr. Lim, can I use a traffic light? Potassium dichromate acidify to obtain. I say this OH will undergoing to be oxidized to form ketone. This one also OH undergoing to form ketone. Both of them also give a positive result. Answer, tak boleh. Then what is a suitable reagent to be used? I know that I refer to the CH3 here. This CH3 tell you about something that it can use to form yellowish precipitate. Which one should be? The answer is here, this one. Iodoform. Okay, which compound? Yes, this compound can able to show you the formations of the yellow precipitation. Okay, fractions, you can refer to your answer scheme. The formation is the medium. The medium we should using iodine under NaOH and under room temperature. Yeah, class 2 yourself, and also you have to complete the chemical equation. Any chemical equation requested? No need. So you don't need to write down the chemical equation. No need. Okay. Meanwhile, for the compound which is NHOO here is considered nothing. Okay, you can write down the result is considered what? Result is considered remain. Clear? Okay, let's say you choose correctly iodoform, give yourself also 3 marks. Clear? Clear, okay. Clear, then should be fine. Okay, so tomorrow, 10 o'clock also I'm going to start for question number 3 and question number 4. Question 5 and question 6, I wish that I will post the question on the Microsoft platform. You will do by yourself. Can or cannot? Can. Then we check the answer tomorrow directly. It's more easier. So I can save more time for question 5 and 6. I spend more time in question 3 and 4. Okay? Okay. So enjoy your lunch. First, I wish that you can try yourself. And for those not yet give it to me any answer, I wish that you can show me using the CS scanner, convert to PDF, and let me know about how the way of your progress. Try your best. I wish this is the last step I can help you in a final examination. Let's say you still do one, I do nothing. Okay, I wish that you can have a good luck when you study all the chemistry, then you can apply it correctly in a final examination. Okay, so thank you very much and class dismissed. Any question, refer to me individually. Yes.
Sir, for the bromine water test, right? For the observation, can I say bromine water decolorizes?
Cannot be. Because bromine water decolorize can be referred to this one also. So we just only have to know the formations of the tribromo here is under the white precipitate.
Okay. Thank you, sir.
Welcome. Yeah. So class, thank you very much and class dismissed. Any
Mr.
question?
Lim,
Yeah, what is it?
for the 1-phenyl ethylamine, the one is not primarily amine. The N only connect to one C only.
No, we got one more here, it's carbon. It's under phenyl group. It's under secondary. It's not primary.
Amine is not the how many C connect to N.
Let me do a check. This one I will do a check later. I will inform you tomorrow.
Okay, thank you, Mr.
Welcome. Okay, but basically we just only focus on the aniline here to show a positive result with bromine water. White precipitate will be obtained. Okay, class, thank you and enjoy your lunch. Bye. Started here. Compound A undergo reaction 1 and reaction 2 to form compound B and C respectively. So outline the mechanism for reaction 1 and reaction 2. Then quickly you try to slow down what is going on. The first one, reaction 1 involve NaOH. Students say, Mr. Lim, NaOH, this is under topic haloalkane? No, they give to you aldo. So aldo should be under which topic? Yes, it's under the topic of nucleophilic addition. Okay, then afterwards, go for another one. Reaction 2 under HCN, product is a cyanohydrine. Still under the same topic, which is under nucleophilic addition. Okay. Outline the mechanism 1 and outline the mechanism number 2. So we try to go through the mechanism itself. Okay, I show to you one by one. Okay, I call the structure first. And I know in the mechanism number 1, the mechanism number 1 is going to what? To produce aldo. Aldo, aldehyde, and alcohol as end product. So I know this topic is to form the compound as well. Now we call out what is a nucleophilic or nucleophile should be. I repeat, nucleophile. Phile, love. Nucleo, positive. Love positive, they mean the compound itself must carry negatively charged. Symbol, Nu negative. Okay, Nu negative. But in this question, they didn't give to you any Nu. They give to you NaOH. So to obtain the nucleophile, which is OH 1, 2, 3, 4, 5, 6 negative. This one we call the nucleophile that we going to be used. Okay, first thing. Then second thing is under to form aldo. Aldo, then I must know the aldo should be formed by alpha carbon. Alpha carbon, which is the H going to be donated or to be protonated. That's why where is alpha? Alpha refers to the carbon next to carbonyl group. This is carbonyl. Carbon next to it we call carbon alpha. Yeah, okay. So first step, ding, 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 the nucleophile appear. Where's the nucleophile? Okay, we write here. OH dot 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 negative. What the OH want? They want H to produce water. So he donate to the H. And the H say, you want me? Can. I must return the pair of electron to the carbon. Both of them, both of them. Always say, yeah, go ahead, go ahead. You live without carrying any negative, any electron. Come closer to me. So the compound able to form the alkoxide like this. Negative, the lone pair electron here, then to form a negatively charge. And lone pair electron, then followed by CO and H. Okay, from what? From water. Okay, because this lone pair electron going to use to form a bonding with H. So that's why to form water, this is the bonding that form. Okay, first step, you score. How many marks? 2 marks. Done, Done. Okay, now at the same moment, this compound containing carbonyl group, they were having the same task, different task. What is the task? Yes, the task going to be have a delocalized for the carbonyl group. Can you see from here or not? Okay, the pi electron going to be attracted by O. O have a higher electron negativity. Then what to do? Yes, when able to form, you will able to have this ion. C with the O, starting which is 1, 2, 3, 4, but now it becomes 1, 2, 3, 4, 5, 6. Because the pi electron here been donated. So you have to put negatively charged. Okay. Here also, the C over here, you can put negatively charged, no problem. Okay. This is negative, then this side should be a positive. And continue by the rest, which is the H that we have. Okay, so far any problem? We still using the same compound to do. Okay, we don't have any extra or any second compound involved. Okay, done already. Now. This is negative. This is positive. What to do? Yes, the electron going to be donated. Here, show the arrow. How long doesn't matter. You just only show to us how the connection to the electron toward the positively charged. Now we can combine. We just copy whatever that we have on this side. This one transfer to here. O with 1, 2, 3, 4, 5, 6 negative, and followed by connected. Like a Lego. You connect it, becomes C. C, we have 2 CH3. Then followed by the C, double bond O, and H. Can you see any changing? No, nothing. Okay, just only connect 2 puzzles of the Lego. Then finally, the water will come again. The water say what? You say, you are not stable now because you have an extra electron. Why don't you take back your hydrogen? So the O say, yes, I have. I donate my lone pair electron to H. And this bonding, I return to the O. Take back your electron. So finally, they can able to form a new compound like here. Okay, just copy the structure without changing the positions. Okay, O now become OH. The rest, just copy. Don't change it. during exam, we don't have extra time to change the structure and etc. You leave this one, we mark it correct because we can have a structure name. We can do a check on the structure. It's correct, even though it's twisted, but we still give the mark. Okay, done. Okay, formed by OH, negative, lone pair electron. From where? From here. This one. Okay, going to form OH negative. Finally, you can see starting is OH negative, finally also OH negative. That means what? It just present as a catalyst. Okay. Can okay. Junyang, can you help me to do print screen today?
Okay, sir.
This is the first slide. Thank you.
Done, sir.
Thank you. Okay. Any question you want to ask? When I see Aldo, I'm very happy because sometimes the question will give to you either it's Aldo or you put as a NaOH catalyst. Actually refer to the same thing. Same thing. Later you got one question exactly the same answer, but just only using different naming or different instruction. You'll be getting confused. Which one should be? Refer to the same thing. Okay, okay, next one. HCN. HCN going to produce, then we're having cyanohydrin. What you do? Same thing. We copy the question, but now you be careful with the new profile. Okay, I show you the answer. First, I copy the questions, the structure that I have. Okay, and now I'm calling what? I'm calling this one C triple bond and lone pair electron with negatively charged. You put this way will be okay. You put this way also will be okay. But you put this way, not okay. Okay, okay, now done already. I'm getting close to the carbonyl group, which is here. What I'm going to do? Yes, pi electron go to the O. O gain the electron, the pair of electron. And here they're able to form this. Don't be panic, just do step by step. You get the answer. Starting which is 4, but after the delocalize, it becomes 6. It access electron, and here is a positively charge. And, okay, with the cyanide, negative. None. Then donate electron to the carbon, or the positive charge also doesn't matter. Okay, then they're able to form this compound. O still remaining 1, 2, 3, 4, 5, 6 negative, and followed by H. Here's a CN. Okay, call back. Call what? Call this one. You put here also can. You put this one also can. Doesn't matter. Okay, what to do? Yes. Once again, the lone pair electron going to have H. H kawin sama saya. Okay, boleh. But you have to return the electron to the cyanide. Okay, no problem. Finally, they can able to generate the final compound at this one. O what? OH. Okay. H with CN. Plus what? Plus the CN that we have. Still the same. Dot dot negative. Done. Is it easy? Okay. So this is the way how the mechanism written. When I see this question, I'll be relaxed because of why the story all the same. It just only attack the carbonyl group. Okay, print screen, thank you. Junyang.
Answer.
Thank you. We are done already. I generate 13 mark. Oh, so easy. Okay. Now you see this question. We see here. See. NaOH catalyst, this one under the condensation, show that you're going to form aldo. We see the same way, okay, but that's only different naming. Yeah, okay. Compound C with the molecular formula C6H2O. Okay. It's acyclic. Acyclic, they mean what? Acyclic, they mean it's not a benzene ring. It's not a ring. I repeat, it's not a ring. Acyclic, not a ring. They mean it's a longer carbon chain. Longer carbon chain. Okay. Carbonyl, it's containing carbonyl, CO. It consists of 4 primary carbon. 4 primary carbon, or is it possible? Later we discuss. Give a positive iodo form. Iodo form, it means what? It means it's a CO, then with the CH3. I know that this compound actually is a ketone. Okay, cannot be here. Cannot be here. Although it cannot be. When you're having the CO with the H, sorry, tak boleh. Must having CH3 at the terminal. Okay, then I have to suggest what is a C compound. How to make it? I suggest C with the O, C here, S3. Then come up with 1, 2, 3. 1, 2, 3, 4, 5, 6. The question stated 4 primary carbon. This is primary. This is secondary. This is secondary. This is also secondary. This is primary. Hey, how to make it become 4 primary? When you come up with a 4 primary, you have the idea already. This compound, it must have a lot of branches. Branches. Which one can become a branches? Here can be connected, become a branches. Like here. CO, then followed by the CO here. I don't know. 1, 2, 3, 4, 5, 6. Then I connect. Now I see. This is primary. This is primary. This is primary. This one also primary. Okay, but this is under quaternary. Am I fulfill the question? 4 primary. Yes, I got 4 primary. They mean this is higher possibility chemical structure. Can. Okay, can. Now, can you answer for me? I want you using this way to show the mechanism of the NaOH condensation on compound C. This one. This one. Okay, and I'm sure students will say, Mr. Lim, you say the aldo formation must be involve alpha carbon, the hydrogen from alpha. This is C. This is C alpha. This C alpha, no H. No H. How to condense? How to form? Hey, don't forget, this C carbonyl group, they got another side. This one also consider alpha carbon. Understand? It's still containing H, isn't it? Still the same way. So I give you the beginning. Hey, I give you the beginning. How the mechanism starting at. Okay. So here, first I draw the structure. I show the H on the alpha carbon. This side, nothing. I just copy it. Okay, don't disappear. Okay, now I call for OH negative. OH negative, help me. Yes, I'm come to help. I take over the H. This one return. So you can able to form a compound here. Okay, to make it more simple, I make it condensed chemical structure form. Plus water. Okay, I give starting already, and now can you show to me your answer? Okay, everyone, try. You can refer to the print screen just now, answer and show to me the answer through WhatsApp. Okay, I give you 5 minutes to do quickly. Show a 3-step reaction scheme how compound C can be synthesized using 2-chloro 2-methyl propane. So normally, listen, normally, when the question give it to you in naming, repeat, I repeat, come on, have a look. We give it to you the naming. If let's say you're totally out of time, don't have time to answer, you draw the structure for here, you can generate for 1 mark, 1 to 2 marks. Understand? At least you draw it. don't let it go. Draw for one structure, you can generate 1 to 2 marks. Okay, so how I do it? So first one is propane 2-methyl. I'm going to draw the structure first. 2-chloro and 2-methyl. Yeah, okay. I'm going to synthesize by 3 steps. 3 steps, so I can form the structure like here. Okay, what should I do? Normally is I will do a check. How to check? I did mention to you. Here got 1, 2, 3, 4. 4 carbon. This one have a 1, 2, 3, 4, 5, 6. 6 carbon. You know already. You know already this must be involved the connection between two compounds through either Grignard reagent, okay, or under the group we added with cyanide. But normally in cyanide you added just only extra 1 carbon connected, 1 carbon only. But here you can see from 4 become 6. I'm sure that this one should be Grignard reagent. Okay, Grignard reagent. Okay, when you come up with the Grignard reagent, the first thing is look at the Cl here. The Cl here, I'm sure that first I am going to make it become Grignard reagent. How to convert become Grignard reagent? Yes, I put magnesium in solid and with the presence of ether. So I can able to form Grignard reagent like here. MgCl. Can. And then look here. I put the scissors here because it's going to cleave, and this C with the 3CH3 refer to here. Then I have to involve something that to make it become alcohol. What can I do? Yes, I connected with this part. This one. So what can I do? Yes, I added with CO with the H and followed by CH3. Get it? Okay. Slash, I have to put number 1, presence of ether, and number 2, hydronium. Okay, hydronium. So I can able to form alcohol. How the alcohol formed by? Here. Look here. Here's OH. This is CH3. This is the H. And followed by the connection with the alkyl group. C. Okay, 3 steps. And finally, I want to remove the H of O here. So to form the carbonyl group, what can I do? I put traffic light. Traffic light, K2, Cl2O7, acidify. Okay, so you can remove H and the H here to form carbonyl group. So finally, this compound can be formed. Okay, let me do for this question. Can you please have a look? Yes, okay, let me go for it. Question B. Depending on the reagent and condition provided, cyclobutene butylenol, cyclobute. Here's carbonyl, carbon number 1, carbon number 2 with a double bond. Here cyclobutene is able to undergo addition reaction 2 different ways, either electrophilic mechanism or nucleophilic mechanism. Explain why cyclobutyrenol can undergo both electrophilic and additions of nucleophilic addition. Now we do a check. Okay, so actually this compound containing what? Contain carbonyls and CC double bond. Yes, here. Carbonyl. CC double bond over here. This one mark. Okay, and what's the special for the CC and also the carbonyls group? They have what? CC and CO consider what? Consider electron rich bonding. Yeah, since it become electron rich bonding, then you have to understand which one should be undergoing electrophilic addition. Hey, Philip, foul electron. Foul electron, that means this one should be carrying positively charged. Foul for the nucleus with a proton. So this one should be under negatively charged. Okay, so which one is under nucleophilic? This one should be under nucleophilic. CO is under nucleophilic addition, but CC is under what? It's under electrophilic addition. Okay, 1 mark, 2 mark, 3 mark, 4 mark. They got 1 more mark. Why is it? Yes. C and C are under sp2 hybridization. Okay, so now outline the mechanism for chlorination of cyclobutene. So under chlorination that we know this is under electrophilic addition. What to do? I show you one. Later I ask you one question to show me. So first one, I show the chemical structure and I need Cl with Cl. So I should connect it here. Form the second compound. Connected to Cl. Cl with a lone pair electron. Starting here 6 already, but now become 8. Okay, done. Okay, Cl itself losing electron, so put positive charge. Now form the electron toward the part of here. So final compound. Ta-da! Done already. Okay, we are focused on the double bond here, so it should be undergoing chlorination. Chlorination under what? Under electrophile addition. Okay, I wish you still remember this is syllabus for test number 1. Okay, print screen, thank you.
Sir, the previous slide haven't print screen yet. Sir,
Hello, boss.
Yeah, done huh?
previous slide haven't print screen yet.
Yeah,
Print it. Print it out.
The previous slide,
The previous slide, which one?
the MG Ether one.
Okay, you print this one first.
This one done already.
Done already. Here. Done?
Okay, sir, done.
Okay, now I want you show me the mechanism. Come, class, we do it together. Now this is, okay, have a look. Compound D undergo addition mechanism. We come on the addition that you know this one should be under electrophilic. Because it's a hard double bond. Let's say it's a CO, it's still under addition. But what type addition? Nucleophilic. Okay, now go through here. Okay, this mechanism undergoing reagent HCl and under carboxylic ion, you will able to form a major compound. Hey, you have to follow the Markovnikov rules to able to form a new compound. At the same moment, you are undergoing to do for Br, bromination, exactly like just now the chlorination. Exactly, just only substitute Br to Cl. You are able to form a F as an intermediate. Okay, now answer for me. I want you to show to me the mechanism of number 4. This one. Exactly same as just now I showed to you, the double bond to the chlorine. Now show to me, I want this compound, compound D, with bromine, Br2. Show me the mechanism. Okay, I gave it to you also 5 minutes to answer. Come, I wait for your answer. Oh, good. Teresa, last compound wrong already. Last compound we show about the Br and Br, it must be one at the top, one at the bottom. It should be under anti-positions. So if let's say this compound, this question, let's say 4 marks, we give to you just only 3 because wrong answer for the final compound structure. Jessie, do you want to try?
Yes, I tried.
Ah,
I left one step.
okay, good. Show me answer.
Okay.
Jessie, second also, lack of one arrow. Here, look at the slide. This arrow.
Okay, sir.
And also the
Yes, sir.
BR. Also, I said that the BR should be upside down. One is at the top, one should be at the bottom.
Okay.
It should be under anti. So chlorination, bromination are the same. Okay, can we proceed? Okay, so draw the formation of major carboxylic ion E intermediate F. So the E answer and the F answer, I did show to you before. Okay, once again, I show to you the answer correctly. So the CH3, triangle, Br positive. Okay, so this is the intermediate for F. For E, they were connected to the H. and the carbon lack of electron become positively charged. Okay, done. So this is the E, this is the F. Print screen, thank you. Topic number 5. Okay, have a look. Compound G react with water in ethanol. Water in ethanol. Students sometimes they will confuse. SN1, SN2, E1, E2. What's the difference? Call the number first. 1, 2, 3, 2, 1, 1. 1, 2, 3, 2, 1, 3. Call the number first. Okay, now do a check. If let's say the question stated there, we just only here, we write down KOH with water. NaOH with water. NaCyanide, then with ethanol. This is the category of SN2. But when come up with the KOH slash ethanol, NaOH, ethanol is under E2. Okay. E1, KOH with water. Okay, am I doing it wrongly? Okay, once again water slash ethanol, and also here. Okay, water ethanol, and this one is under OH, water under water. Okay, so normally is we will through the questions to understand what is a question 1. Okay, we check the structure first. Structure G, Cl with the C attached with 1, 2, 3. So this is under a tertiary haloalkane. Here, refer to here, this one, and this one. Now we do a check. We want to know is under SN2, E1, or E2. Look here. Water in ethanol and ethanoic chloride respectively to form different H and I. So they mean this compound, they will form 2 compounds, give hints already. This one should be, yeah, is an E compound that we have. E. E what? E, look here. Water in ethanol. Water in ethanol. So this one should be E1. Refer to here. E1, okay. Tertiary haloalkane. E1, how many steps? 2 steps. 2 steps. Okay, let me check. Now see, water in ethanol under E1. Number 1, 2, 3. Okay, compound H is a major product. So that means we are undergoing to remove the HCl. Yeah, HCl. How are we going to remove? So we show the chemical structure clearly. Can you put down your pen? Look at here. This one, I draw the structure. And send the CH3 and the Cl under the adjacent carbon, under the same carbon. So this one actually you can twist that. Okay, to remove, this one can be removed. HCl, another side here. Okay, so they can able to form 2 compounds. Compound number 1, compound number 2. So which one is major? This is major. Because CC with the 1 two of the alkyl substituted major. But this one under major. Why? Because C double bond is just only one alkyl substituted. So this is under minor. Okay, okay. The question said that compound H with the major compound. Here, this one. Yeah, okay. Now look at the questions. State the rules that occur in reaction 5. Reaction 5. So the rule that we're going to use is Zytec rules. State the type of mechanism in reaction 6. Reaction 6. Reaction 6 looks so familiar, but to know how to do, have a look. Ethanoyl chloride, eth 2 carbon, chloride Cl. Ethanoyl, this is under the acid highlight, topic number 8. Yeah, here. Ta-da. Then this compound undergoing to have the mechanism to form compound I under auto positions. Hey, it means what? It means this compound, I rub it first. Hello, look here. I rub it. Then I know this compound under the topic of benzene ring. Benzene ring, the mean is under the part of alkyl group. This whole thing is under alkyl. Alkyl. So when alkyl attached to the benzene ring, we know that you are undergoing auto para directing activator. That means you are connected on here or on here to form two different compounds. Can? Okay. So now name the mechanism. The mechanism. Topic number 3, we study about CC. CC, just now, we study, we call this one under electrophilic addition. Okay, and topic number 4, we study about benzene ring. Also the same. We call the mechanism as a electrophilic, but now it's a substitution. Penuka ganti. They mean one in, one out. Cinderella. You still remember? Cinderella is under electrophilic substitution. But when you go for C double bond O, topic number 7, this is under nucleophilic addition. Okay, since you give it benzene ring, so this compound, answer electrophilic substitution. Okay, now draw compound H and I. Then I know this is the compound that we have. H equal H, and I equal this. Auto connected to this part. Which one? Connected to here. Put the scissors. Cut. CO, then followed by CH3. Be careful, draw compound plural. So that means write properly all the possible compound. H what? HCl. Okay, this one also going to remove the H and the Cl. You put HCl. How many mark? 4 mark. Okay, here each compound 1 mark. Any problem? Look very difficult, but I focus on here. I know what is the way, the answering way for this question. Okay, print screen, thank you.
Sir,
Mm-hmm.
can sir show the red law one answer?
Which one? Which one?
The 4A1.
4A1. State the red law. Red law in fractions 5. Fraction 5 over here. 5. 5, this is under what? Under E1. E1 refer to here. E1, which is 1, 2, 3. 1, stay for E1, 1 rectangle. I repeat, 1 rectangle. 2, 2 steps. 3, tertiary haloalkane. So the red law, which is red, equal to K, and refer just only one substance. Which one? This one, the major. Draw the structure into the column. Yeah. If let's say it's a E2, then you have to involve what? Involve this one. The here, ethanol, the water itself. Okay, so if let's say E2, you have to put one more bracket and put H2O. Since E1, just only one.
Okay, thank you, sir.
Welcome. Any question you want to ask so far? So if let's say you ask me, Mr. Lim, it looks so easy, but how can during exam be confused already? Because of why? In organic, they can overlapping in between topic to topic. It's not like physical chem. Physical chem is reaction rate only. Then you won't come up with second topic question into it. But organic, you're overlapping each topic one to each other and come up with the answer. So the main higher chances is you will go to wrong way. Understand? So that's why you're getting confused. Why so difficult to remember? This is called organic. Can I class? Now is the time for you to answer. Have you ready? Can I? Okay. Now answer for me. Draw the mechanism for the reaction compound G in water in ethanol occur in reaction 5. Can I? Okay. Choose either one. I want to see either you know or not. Okay. First one is we under E1. E1, 1, 2, 3, 2, 1, 3. You must involve 2 steps. 2 steps mean what? They are able to form carbon cation. Yeah, okay, this is under E1. Meanwhile, for the part of number 5, they ask you the ethanol chloride happen in reaction number 6. So this compound under to be reacted with this one. Hello. Okay, at the auto positions. Okay, now kawan-kawan semua, I give to you option. Choose one to answer, but make sure that you can refer to your lecture note and answer for me here. I gave hints already. Number 1 and number 2. Okay, choose one to answer. Either number 4 or number 5, select one and show to me. Or you want to show both also can. Okay, I give you 5 minutes to answer. Come, do it now. One, two, three to the C and the H. C with the CH3 and Cl. Okay. So I'm going to be reacted with Al. Okay, let me do a check. Okay, this compound. Okay, show the mechanism. Can you put out your pen and have a look? Hello, can I? Okay, first one we are going to do here. Okay, so this is under the area, so it should be under two-ways arrow, unless it's under the part of, let me see. Okay, yes, area. Okay, Dana. Okay, this one I gave generate 2 marks. Cinderella, go. We go to the palace. Okay, Cinderella knock the door. Can you let me in? I say, no problem. We show that the formations of the electron toward the positively charge. Okay, so I'm allow you to go through the door of auto. Auto, mana? Ini. This auto. Auto so the upper door is open. Yeah. Open, we will connect it to the CO and the CH3. Remember? One more H. Originally, this one more H over here. Okay, so they got one more H, but here losing the carbon, losing the pi electron here, you must show it's under a positively charge. Understand? Okay, okay, then at the same moment, the AlCl4 come to busybody. They say, hey, you want to formulate the final compound, take my Cl at the end to form HCl. To who? To the H. The H say, can, but I have to return the electrons of my bonding to the positively charged. So finally, we were able to form what? From this compound. 1, 2, 3. Plus. Done. Print screen, thank you. So far, just only the Vinesh show me answer. The rest, you okay or not okay? Not okay.
So there is a COCH3 right at the auto.
Yeah, thank you. Yeah. Thank you. Done. Okay. Now we go for the second mechanism about the elimination for E1. Can I wrap it? Print screen already? Now I go through here. This one. What I'm going to do here. Then we're going to form this compound finally. So this compound under which type of series? Yes, under the part of E1. E1, how many steps? Ask yourself. 1, 2, 3, 2, 1, 3. Here, E1, 2 steps. So step 1, we are going to form the carbocation. Yeah, so carbocation. Return it. Ding, 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 ding. So form the carbocation. Plus Cl negative. Okay, step 2, we have to use water come out to remove it. Okay, but normally it's hydroxide. So what you're going to do, we call hydroxide come to take over the H. Here. The H over here and OH negative 1, 2, 3, 4, 5, 6. Go to the H return the bonding to the CC. So finally, this compound can be obtained. Can? Okay, so this is the carbocation formation, and under the E1 to remove water are correct. Print screen, thank you. Not using alcohol, but we know that Br here we can convert become Grignard reagent. Okay, so I give to you the answer here. So first thing is the Br itself we convert become Grignard reagent. Mg Br. Okay, done already. And we know that this compound can able to let us MgBr by CO2, the dry ice. So this way can be converted. Done. Okay, we put water under diluted H2SO4. To form carboxylic acid. Then this OH going to be substituted by what? By here, SOCl2 and H3. So finally, they can convert this compound. Okay, print screen, thank you.
So,
Yes.
may I ask when in the exam, if I stop at I cannot continue to the end product. I stop at the third product. How much I can get it?
Normally is we will see how logical way that you conducted. For example, you have a BR, then you go through the formation of Grignard reagent, we still give it to you the mark. But if let's say the Br you converted become alcohol, and we will think about, is it possible finally they can form back the final compound? Is it one of the way? If let's say yes, we still give to you 1 mark. If let's say no, illogical, so that means we'll stop there. Okay, it depends to how logical way that you conducted to answer.
Okay, thank you, sir.
Welcome. Class, Okay, let me go for some simple question. Here's another mechanism. Sulfonation of benzene produce benzene sulfonic acid here. Okay, outline the mechanism for nitration for benzene sulfonic acid. Now this is the benzene sulfonic acid, and you have to clear about this is under which category. Yes, this is not auto, para directing activator or deactivator, none of them. This one is under the part of meta directing deactivator. Just only one answer can be obtained here because you're under nitrations. So finally, this compound can be obtained. Yeah. Okay. Now, before this, give it to me the mechanism. Now I give to you freely already. So think about it, how the nitration should be from the presence of concentrated nitric acid and concentrated sulfuric acid. Okay, it's quite simple. Do it and answer for me. When you attach the answer, you put it there. Did you without reference or with reference? Do you understand? Okay, I give to you 5 minutes to answer quickly. Question number 1. Okay, Zuho, well done. Let me check the answer from Jessin. Jessin, it should show to the arrow should show to the NO, the O. And the plus don't keep far away. Hello, here, Jessin. NO to here's a positive. You put here, it's totally out already. How can it be? Close to it. Yeah, don't let any of the mark examiner deduct your mark because of the format.
Okay.
And Jessin, SO3, not SO2.
Sorry, sir, my careless.
Be careful.
Okay.
And furthermore, what is the end product? End product is H2SO4. Remember, each of the side product also containing mark, so don't let it go. You want me to show? Okay, I show you slowly. So the first way that we need HNO3. Okay, 2 head arrow with the presence of what? Sulfuric acid. So they will form nitrogen ion, HSO4 negative, plus what? Plus, is it plus water? Plus water. Here we call electrophilic. Benzene ring, SO3H. Meta positions going to be donated to positive NO2. Intermediate, Okay, so this is the way how the mechanism can be conducted. Number 3, explain why nitration of phenol occur at a much higher rate compared to the nitration of benzene sulfonic acid. So, this is benzene sulfonic acid, this is phenol. Why? Why? Because OH group is under what? Is under the auto para directing activator. Okay, so 1 mark for you. Second mark, because of the auto para directing activator can able to form 2 major end product. Second mark. Okay. Third, because of the delocalized of the benzene ring, okay, which is under the auto and para positions, so we were able to form a more higher stabilized carbocation. Okay, and the last point, which is refer to the compound itself, so the end product can be produced even with a higher rate with the auto and para activated positions. Okay, you may get the answer, another answer from our tutorial. Okay. Can I class? Okay, so this is the way that how the questions can be conducted. Okay, so I leave it here. You can think about how to solve the question number 4, A, 1, and 2. So I wish that you can give it to me the answer directly. Yeah, okay. Now we go to question 5, 6. We finish all, then I close the revision session for it. Okay, let me try. J and K going to produce the compound. This is under acid anhydride. Acid anhydride, quickly we put the scissors. Yes, we know that they're able to form by 2 carboxylic acid. So which are the 2? Here. First carboxylic acid, second carboxylic acid over here. Okay, J and K. So remember when you answer for here, draw the structure carefully. Don't lack any extra carbon or hydrogen. Next one, number 2. Yeah, L and M. Be careful, Cl refer to the Cl here. If let's say it's a Br bromine, should be under bromine. Don't make mistake. Can I check your answer, class? Next one. This compound undergoing to form, draw the product when reaction F reacted with potassium hydroxide, KOH in ethanol. Sounds so familiar. Why is it? Yes, we know this is under either E1 or E2. E1, E2, okay, where? Here. Okay, and we expand the chemical structure, the chemical can be formed by another site. So they can able to form two compounds, which are here. This is the first. Secondly, then added with 5 bar. 5 bar that means each chemical structure 2 marks, 2 marks, and one more mark over here, which is HCl. Hydrogen cyanide. Hydrogen cyanide HCN going to be attached over here. So the compound copy exactly whatever that you have in the structure. Don't do any extra conversion. Done. That's okay. Now we go for here. Oh, this compound. This compound, cool. Cool, it means we put 2 OH. Q here. Done. Then afterwards, we put Na metal. Na metal, they mean 2 of the H here will be combined it to form hydrogen gas. And these two compounds can be obtained. R. Done? Done. Okay, this compound undergoing to form what? Hot. Hot, they mean cliff over here will happen. Cliff, so they're able to form two compounds, N and O, to form two different ketones. Okay, and be careful, because you are going to put OH germ diol. Germ diol, then you should refer to the compound with the CH3, CH2, CH3. So this is referred to compound O, and this compound N. 10. 1, 2, 3, 4. 1, 2, 3, 4. 4 carbon. This is just only 3. So undergoing the Grignard region, be careful, Grignard region, you form P. Remember, without any hydronium, you have to stop at the middle. So this compound can be formed. Compound P. Okay, print screen, thank you. So that's why I propose to student when you go for final examination, quickly go to question 5 and 6. Rough out or maybe write out the answer directly on your answer script. Understand? Don't wait don't wait, because question 5 and 6 is most easy, and also direct to the answer you score. You can able to get higher marks. You focus too much in question 1, 2, 3, 4. Actually, you need time to answer. But 5, 6, strictly, you can answer by just only structure drawing. Sudah clear? Okay, answer 5, 6. We won't deduct any mark. If let's say starting from question number 5, you answer all, then question number 3, then question 1, question 2. But make sure that the whole answer that you answer at once, then we will accept. Don't jump question. Jump question means 1A, then go to 5C, then go to 3D. This one really make us struggle during our marking. Okay, be done already. Okay, now we go through here quickly. This compound under UV and the Cl to form G, tertiary halide. So this compound can be obtained. Cl. Okay, okay, good. So that means, sorry, okay, not under E1. It should be under OH. Yeah, OH going to be substituted. So this compound can be obtained. Because I don't have the answer scheme. Okay, let me do a check. Okay, good. Okay, now they're going the potassium permanganate, so they're able to form a T. Okay, form a T, they're able to form. Oh, it's so weird. This one refer to H. KMO4H going to reflux. Then any changing? It's OH here to become aldehyde.
So can it be carboxylic acid?
Yeah, I'm thinking about it. Okay, thank you. Because it should show 2 arrows. Should show 2 arrows. Okay, these questions are not in a proper way. It should show that alcohol here undergoing to form aldehyde first. Aldehyde first before you form the carboxylic acid. Here, carboxylic acid. Then afterward, you go for the reagent. You want to form ester. So here's ester. Clear for it, then we're going to add up with OH. Then with the presence of sulfuric acid. Okay, thank you very much for the student. And afterward, we put sodium hydroxide. Sodium hydroxide, then you can see that the formations of, if let's say under NaOH, then they're able to form the compound here, O with the with the J with the water or H2O, half H2O. I refer to this question student, that means the coordinator, how they set the questions. Okay.
I write salt.
You wrote as a salt. Let me see. It's a salt. It's a salt then followed by water. If let's say J is a salt, O and A. Okay, let me check. Let me see. If let's say you put salt, then it should be okay. You'll be able to form water. Okay, so sorry for the mistake here. So we can able to show here it should be 2 arrow. It means we can able to see that it will form aldehyde, then followed by carboxylic acid. Okay, let me see. Just only single arrow. Single arrow, that means what? Ayo. Headache. Okay, so thank you very much. And this is the B answer. Okay, but if let's say your answer quite same with mine, mark yourself each correct structure for G, H, I, and J, make it 2 marks each. Suggest reagent. So the reagent, alcohol. Yeah, reagent. We didn't stated about the catalyst, if let's say you settle catalyst, also doesn't matter. Because of what? Because the question given to you is under 2 marks. So structure actually is 2 marks. Catalyst normally we put 1 mark. Normally, but since just only 2 marks, structure is more important. Okay, print screen, thank you.
Answer.
Okay. Okay, then question number C, under alkene as a molecular formula, which is under symmetrical. Symmetrical, here is a symmetrical. Okay, symmetrical way. Okay, then afterward, undergoing the hydrogen bromide to produce U. U further we plug with aqueous sodium hydroxide to form compound V. It means you need to use OH negative. So the compound itself. And this question actually is a bonus one for you. Here, to form OH. Okay, so anything, nothing else. Reduce the structure. TUV. Yeah, done. Okay, then the rest of question number C here, I think which you can do the same way when you go for the answer. Okay, so question number 6, quite similar. We go faster. Okay, complete the following equation by drawing the product form. So we got W, you got X here, the compound acidify, then followed by heat. So what you're going to do? Yes, we know we are going to cleave the chemical structure. Here should be. So this compound can be obtained. One H here. Okay, during exam, don't so OCD. When you come up with a structure with the correct carbon number, then let it go. This is the answer. Okay, go to another side. Here also. Okay, if you realize actually 2 of here consider same. Then same here, how can you go X over here? X over here, that means both of them going to cleave together to form a final compound. Clear or not? Okay, they are same. So how to cleave become the same? Here should be. Okay, so draw whatever possible answer and we'll select the correct answer for marking. So they got compound 1, compound 2, and compound 3. Done? Okay. Then afterwards, this compound I'm going to do, and we know that this is under the part of, yes, the area acid halides, COCl. Also undergoing 2, it means you have to be careful when you answer it. So the chemical structure here. Yeah, then furthermore, HCl is a side product. So that's why 2 plus 1 mark. Okay, next one. The structure O is under the structure that we have. Draw the product reaction O with dimethyl aniline that we have. So the compound we have CH3 with a H. Secondary amine. Okay, where put A? Okay, this compound going to be react and we remember all the time we put scissors over here, cut. So diethyl methyl, then they can able to form the compound here. O then going to remove by here and by the connection of NH that we have. So connected and CH3, CH3. Okay, and formed by one more cleave, H should be connected. So the side compound, alcohol. Done. Acidify KNO4. So this one is conversion of OH become C double bond O. Here. But be careful, you must know about the oxidizing agent going to remove 2H. Although the CO with the 2H attached, H number 1, H number 2 going to be removed. C with the OH, none of the H here, oxidizing cannot be happen. So the end compound can be like this. Understand? Compound. Okay. Name the type of reaction happened in Q6A1B. A1B, so under oxidizing, then you know this under the process of oxidation. Okay. So what about here? The B compound. Quickly how we do it. Okay. So just now we mentioned already NH2. So this is under the SOCl2. Let's say you still remember. Okay, but this under SOCl2, but this is not compound C. Okay, what you're going to do, you do slowly. Lithium aluminum hydride, so then you can able to form a compound like this. Okay, HNO2, they mean they were able to form carboxylic acid. What gas? N2. Water, A, carboxylic acid. Okay, something that undergoing oxidify potassium permanganate. Reflux, that means you have to know this compound is under the D, attached with COH. Let me see, let me check. And not just convert, Okay, without the presence of NO2, NO2 cannot be. So this one refer to the compound NH2. Should be under the alcohol. Okay, diluted reflux. We're very happy when you see this one. Sure that you're going to form ester. So this compound can be obtained. Okay, compound E. State the observation for the reaction between B and HNO2 and name gas F. So you can see the B itself with the presence of the nitric acid. It means what? The gas bubble is released. Then name the gas F. What is it? Nitrogen gas. This one to show you the presence of what? The primary amine. Okay, class? Okay.
So
Yeah, what is it?
for the A should not be alcohol, man.
Is it alcohol or carboxylic acid?
I think it's alcohol.
Can you check for me? Double confirm.
是的。
Aha,
I also agree it's alcohol and
it should be alcohol. Let me do a check because I don't have the marking scheme. Okay, so so what our alcohol should be?
CH2OH.
By nitrogen gas, by water. Am I right? Check for me.
Yes.
Okay, done. Okay, now quickly we go for further. Okay, how the chemical structure look like? Draw structure PQRS. So this compound under region to form a compound over here. Now we know this under exactly the question that we studied just now. So it's a CH3, CH2, then followed by Cl. Cl or Br up to you, but make sure that you should attach. Okay, then furthermore, go through the Br, so they're able to form primary halide. So how the primary halide look like? Here. CH2, CH2 followed by Br. Okay, using NaOH with ethanol and going to reflux. So this is under what? Under the elimination process. So the compound can obtain as here. Get it? Okay, done already for P. This S. This is region number 2. Any more? Q. Q is cyanide, ethanol, and reflux. So we know that this is under SN2. SN2, SN2, the compound can obtain like this. Okay, finally, reductions. The final compound can be obtained like here. CH2, CH2 with a C, and to the benzene ring. And followed by SO3, H. Okay, so let me do a check. 1, 2, 3 carbon should be attached. 3 carbon, 1, 2, 3, 4. One more extra carbon. Okay, I wrap it.